All right, hello everybody. This video is specifically for second period because the whole fiasco with today, we had a shorter class period. You need to have your green notes out. We're going to go over pretty much a whole bunch of pages in the green notes. Okay, some of this you've already got in class, but we'll go over it really quickly. So find this page in your notes. It says discontinuities here. And you need to just write down all the red words. Again, the d of x represents your denominator, n of x is your numerator. And if you set your numerator equal to 0 and solve for x, then you get your x-intercepts. If you set your denominator equal to 0 and solve for x, you get your vertical asymptotes. But if you have the same number from both the denominator and the numerator, then that becomes your removable discontinuity. Okay, we reviewed that in class today and we saw it yesterday. All right, moving on to the next page of your notes. This was some examples. I think we got through a couple of them. Basically, if you have removable discontinuity or a vertical asymptote, you have an undefined term. Basically, if you look on your graph and pull up your table, when your x is -5, then your y value will be undefined. Okay, and then anytime you have an undefined term, that's going to affect your domain. And so instead of having your domain of like -infinity to positive infinity, where that break is at -5, you have a little conjunction there. Okay. And then another example, I'm not sure if we got through this in the class or not. Again, you're setting your numerator equal to 0, solve for x, set your denominator equal to 0 and solve for x. And in this case, whether you use the -2x plus 12 equals 0 or you just set the factor x minus 6 equals to 0, either one, your answer is going to be x equals 6. Okay, for the numerator, and then the denominator, you're going to set both of those factors, this x here and the x minus 6 equal to 0, and you'll get the x is going to equal 0 and 6. Now, because you have 6 from both the numerator and the denominator, this 6 is going to be a removable discontinuity. Remember, RD stands for removable discontinuity, and then the 0 is your vertical asymptote. Both of those terms are going to be undefined, and so both of them will affect your domain. Okay, and then for horizontal asymptotes, remember these rules. If your numerator's degree is less than the denominator's degree, your horizontal asymptote is at y equals 0. If the numerator's degree is equal to the denominator's degree, then you divide your coefficients. And then if the numerator's degree is greater than the denominator's degree, you do not have a horizontal asymptote. You'll end up with either end behavior or a diagonal asymptote. Okay, these are 3 problems that are also in your notes. All you have to do is tell me whether the degrees are equal to each other, less than each other, or greater than each other. And in this case, these are the answers. And then I had my other classes, they told me what, based on the information from here, they determined where the horizontal asymptote was. So notice for this one, we took the 4 for the leading coefficient of the numerator divided by the 2, the leading coefficient of the denominator, and we just got 2. Okay, here you don't have to do any math, it's just y equals 0, and then here we have no horizontal asymptote. Okay. So if you don't have a horizontal asymptote, then you will have either a slant asymptote or end behavior. Another couple of terms that all mean the same thing: slant asymptote, oblique asymptote, or sometimes it's called diagonal asymptote. All of them mean the same thing. And basically, your asymptotes are at an angle like this one. And to find this asymptote, you have to do long division. Okay. So this is problem 14 from the work yesterday, and we set our numerator and denominators equal to 0 to find our x-intercepts, and notice our x-intercepts are at like -1 and 2. This graph is not drawn very accurately, but that's the basic picture of what the graph looks like. Your vertical asymptote is at +1, And then the diagonal asymptote or oblique asymptote, we found that we did long division, and we found that the formula was at y equals 1/3 times x. Okay, and so when we were drawing this, or when we were trying to draw this, we would graph this equation in f1 of x in the calculator, and then we graph this equation in f2 of x. Okay, and that's how we got this graph. It looks really, really cool. All right. This is an example that's in your notes, and I told my students today that you'll have a question or an equation like this in the test, and then you're going to have to find x-intercepts, the vertical asymptotes, horizontal asymptote, removable discontinuity, and then slant, diagonal, or oblique asymptote if there is. Okay, notice in this equation we don't have a horizontal asymptote and we don't have removable discontinuity. But we do have a vertical asymptote at -3. We just set this equal to 0 and got -3. And then we set this equal to 0 and solve for x. I'm not sure if this is the right answer, honestly. This is a crazy quadratic equation. If you want to find the right answer, you'd have to use your quadratic formula. And the good news is on the test, you're not going to have a really crazy x-intercept like this. It'll be like x equals 2 or x equals -1, something that's very easy, whole numbers that are nice to work with. You're not going to have a problem that's crazy like this. So I'm not sure if this is the wrong answer. I know. I'm just showing you this is basically what type of answer you'd get if you use your quadratic formula here. Don't freak out. You're not going to have a problem this hard on the test. Okay, but moving on. So we don't have horizontal asymptotes. We don't have removable discontinuity because this is not the same answer as that. And then for our oblique asymptote, we did long division. And this one, I didn't even do the long division with my students. I had them try it out, and they told me the answer was 3x minus 5. Please, in your notes, go ahead and show me all of your work. When I check your notes on Tuesday while you're taking the test, I am going to look to see if you are showing your work here. All right. And then for end behavior asymptote, you do need to, this is also in your notes, you need to write down that you're going to get your answer from the quotient. And essentially, most of you know, but in case you have forgotten, your quotient is the answer up top here. When you do long division, that's your quotient, okay? It's not anything crazy or strange. It's just your answer up here. It's a fancy way of saying your answer, all right? And then your remainder, we don't really care about the remainder. If you want to, you can include it in your answer for this is your formula for the end behavior asymptote. You can include it. You really don't have to. Most of the time, and even when you're in college, you're not going to care about this. You know, yes, you could write it there if you want to, but when you're doing your formula for the end behavior asymptote, all you have to do is type that in, okay? Now you'll notice one thing. If your denominator is a linear equation, so your degree is 1 in your denominator, then you can use synthetic division when you're trying to find your diagonal or slant asymptote. Just be careful. The biggest difference between having an oblique asymptote and an end behavior asymptote is with, let's go back one, actually two. With oblique asymptote or slant asymptote, notice your degree here is 2 and your degree here is 1. So there's only 1 degree apart, which will give you a linear equation, so you'll have your slant asymptote. Here, all of your equations here, your degree is 3 and your degree is 1. So you're 2 units or 2 degrees apart. So anytime you have degrees that are 2 or more degrees apart, then you're going to have end behavior asymptotes. And it will be actually an equation. Most of the time it's a parabola. Sometimes it may be a, what am I thinking, cubic function, okay? Just depends on how many degrees apart they are. All right, so number 20 is another example in your notes. And again, this graph was just drawn very quickly on the board. If my points are not exactly where they should be, don't stress yourself, but this would be the basic shape. Your blue is the actual graph of your rational function here, and then the red dotted line, that's your asymptote of right here. And I just realized we forgot to draw the vertical asymptote on here. Let's see, is it red? Yeah, it's red. So your vertical asymptote would be somewhere like this. So with these, you're going to have vertical asymptotes, and you'll have either a horizontal asymptote or end behavior asymptote or a diagonal asymptote. Okay, so you can have more than one asymptote, but you cannot have both horizontal and end behavior or both horizontal and diagonal. Okay, so let's see, that's the example. I think that's the last example. Yeah. So that's the last example we did in class, and then there were 4 practice problems to do. You need to get those done before Friday. That's when they're due. Okay, I know I feel so bad having you guys watch 2 videos. Sorry about that, but I do want you to get all your notes on this, okay? All right, let's see. I need to go ahead and close this. So don't forget to watch the other videos as well, okay, guys? What am I doing?